Why do we apply lime? What is lime? What are other types of fertilizers? Why is lime important to those fertilizers? To answer that question, the number one thing we need to do is learn how to read a soil test. And since we're on the topic of lime, we're on the topic of calcium. You guys are looking at a screenshot of a soil test from our farm. As you can tell, a few of these sample IDs need to have some attention. How much lime do I need? How do I apply it? The quickest and easiest way to look at your soil sample is to look at the pH. Then look at hydrogen. Hydrogen should be 0. If your hydrogen levels are high and your pH is low, that means you need to apply lime. Now if your pH is higher than neutral, which neutral is 7, then chances are you have poor drainage. Which secure to poor drainage is drainage tile. But in our western Iowa area, that's not very common that you'll run into that issue. Usually it's low pHs. The next question is how much or where do I apply lime? What do I want my pH to be? Well, neutral's 7. However, it depends on what you're growing. For example, corn likes about 6.3, whereas soybeans like 6.8. Alfalfa likes a perfect 7. Or if you're somebody like raising blueberries, they like it in the 5s. So for our farm, which primarily raises corn and soybeans, we like 6.3 to 6.8 in our soil tests. The number one factor to getting your soil in health and getting it to where your herbicide will work, your plants will have perfect nutrient uptake, is getting your pH balance just right. And that comes from lime. So it probably won't matter if you apply P and K or other types of trace minerals if your pH balance is off. It can also affect such things as herbicide and just general water intake and holding capacities of the soil. So before you worry about anything else on your soil sample, your N, your P or K, or your traces, get your pH balance in check. How do I apply lime? Well, you use a dry spreader cart, which is what we just purchased if you go back and watch the video of the BBI spreader, which I have been getting a lot of questions about. I'd like to address a few of those questions right now. This is my last video, but this is that dry spreader cart. And this dry spreader cart actually received quite a bit of questions on it. You know, when I first started researching these carts, they seem simple, but the more I went to study them, the more complex it became. What makes them complex is almost every cart is different. I actually had some questions. Will my hydraulics run this cart? Well, I don't know. It does take a fairly large amount of hydraulic flow to run because this is not a PTO cart. If you didn't have that flow, though, they do sell a PTO option that runs its own onboard pump, and then you, of course, could run it with probably 80 horsepower. All you gotta do is pull the weight. I didn't want the PTO, didn't want all the extra drive lines. This is coming directly off the SCV, and we could run it with lesser SCVs, but it's not going to throw as far, so you'd have to do a pan test to determine your width to throw. So basically, you're looking at what you're wanting for a quantity minus your width and spreading ability. That's what a pan test is. Then the computer algorithm will plug in and vary it from there. I was also asked about this chain, and several guys had some concerns, several guys liked it. The chain is going to be your best bet for fertilizer and lime, period. This chain here. Even a belt over top of a chain, when you get like a lime sticking in the box, this will chew on it like a cheese grater, whereas a belt can slip on it. So in my opinion, this is the way to roll. And this is very precision for fertilizer because each little bit of fertilizer sits in these pockets instead of just having a big bar. But you do have to remember this is 20 inches wide, whereas like a Simonson cart would only be about this wide. And when you only have this many pockets full of fertilizer, you can go down to a very low rate. Whereas this chain being wider at the very lowest rate possible, just, you know, even if you just barely tick this chain over, you still got each one of these little pockets full of fertilizer, so that's probably going to equal about 25 pounds at the lowest end. But on the upper end, the machine will spread multiple pounds of lime. You can go 6,000 pounds an acre, or whatever you want at 8,000 pounds an acre. It will do it. I mean, it's just depending how fast you go, and I'm about to show you guys a video out in the field. Now back to these soil samples. Take a look at your base saturation, and here's a quick list. Hydrogen, you want it to be 0 to 10%. K, you want 4 to 8%. Calcium, 65 to 80%. Magnesium, 12 to 25%. And under ideal conditions, all those add up to 100%. A lot of people are going to say, well, my K levels are 2 to 3%. How do I get that to that 4 to 8%? Well, first thing you need to do is you need to have everything in check to be able to utilize your K, which comes again from lime. Getting that pH balance in check. How much time do I need to put on to get my pH balance in check? Well, that's the big question, and that's where you use a buffering index versus the pH balance, and then you'll know how much to put on, and you can go cross-reference that over on the internet. There are charts available to hit your desired target rate, and again, that's going to be based on your cubic density of your product as well. Here in Western Iowa, we have good limestone, which lime is essentially ground up limestone. We have about a 90 pounds per cubic foot product here, which is a good product. In other areas of the United States, they use dolomite, which is basically the same thing, a little different chemical makeup. K is potassium. Potassium is kind of like having a meal on your plate and an empty refrigerator versus a full refrigerator. So if you use your parts per million on a soil test, there are mathematical formulas that get you to removal rate, meaning what you have to feed the plant. That would be like having a cooked meal on the dinner plate, but nothing in a refrigerator. So yes, it will feed the plant, but with no surplus. So if the plant becomes stressed or there's a reason that the plant needs to have more food, that's where your base saturation level should be between 4 to 8%. A lot of guys will say, well, I got a 2.8. How do I get that between a 4 and 8%? So if you have a base saturation of 4 to 8%, that'll cover that plant as need be basis. And if fertilizer is cheap, you can build that up higher and then ride out the bad years where maybe fertilizer is higher, you don't have as much money. So anyway, what you do when you figure this to get your base saturation, we like to see a base saturation of 4 to 8%. What you need to do to get it into that area is the K you need, take the parts per million of K times 4, and by the way, this is a 0 to 6-inch soil test. Then divide that number by your base saturation, then that number minus your parts per million. Let's do a worksheet together. Go to line 2 here. You can see that we have a parts per million of 207 and a base saturation of 2.8. 207 times 4, that'll spit you out a number of 828. Then you take that 828 divided up by your base saturation, which is 2.8, equals 295.71. Minus the original parts per million equals 88.71 pounds are needed. Again, you will not get any uptake to your plant. You could pile on 1,200 pounds an acre if your lime is off, if your pH is off. You have to have balanced pH for proper plant uptake. So until you put your K on, until you put your P on, until you put your other traces on, make sure your plant has the ability for uptake, which comes from pH balance. Once your pH balance is correct, then your plant will have enough uptake to utilize the other trace minerals. If you're interested in how much your plant needs, you can go online and find multiple yield goal calculators, which, by the way, you should be using realistically and not just saying, well, I got a yield goal of 300, when you know good and well no matter how much fertilizer you put on the ground will not produce above 170. So try to set a realistic yield goal for the ground, and you can look at your removal rate for grain and stover. Usually I figure both of those because the plant has to have something for the plant itself as well as the grain, and that'll give you a pounds required for the plant or the amount of removal. There's a lot of factors that go into this that I didn't discuss here, such as organic material breakdown, which is going to have a certain level of micronutrients within itself. And if you are going to be applying this broadcast style, you really need to have a good spreader cart and conduct a pan test so you're making sure that you're spreading evenly. The purpose of this video is just to give a quick reference for fertilizers, a quick reference calculator to figure out how much is needed. But again, none of that matters if your pH is out of check or you have a lousy spreader. And if you are applying broadcast, you need to kind of work it in. We really like to band the product in. Your P's, your K's, they have a tendency to sit in a certain strata of the soil, and they take years to get down to where they're needed. They really need to be in that 3 to 6 inch zone. Same with lime, it's going to take time. Same with lime, don't expect a quick turnaround. It could take several years to work down. If you have a soil that's 5.5, 5.7, pretty acidic soil, you might be looking at 5 years so that lime gets down there to where you're in the 6s or where you need to be. It's not going to be a very instant turnaround. That's why on our farm we found it important to have our own cart. We're going to start monitoring soils. Anything 5.9 is at this point what we're going to call drastic. We're going to really try to hone in on that 6, 6.1, 6.2 and go out and throw 800 pounds, 1,200 pounds and keep that soil in the 6.3s, 6.5s versus letting it get down there and trying to go out every so many years with like a 2-ton application. The main nutrient for corn growing is nitrogen. Other crops such as wheat also need supplemental nitrogen. Corn is going to be the #1 crop for the most supplemental nitrogen, meaning that it does not produce its own. Soybeans actually use more nitrogen than corn, but they produce their own and in fact leave some residual in the ground. Say 60 bushel beans will probably leave you around 45 pounds of nitrogen, and nitrogen is probably the worst test on a soil test to see what's there. It's the most incomplete or inconclusive. And again, you can go to a yield goal target chart to verify and decide on how much nitrogen you need to reach your yield goals. Anhydrous ammonia is a widely used and fairly cost-efficient way of applying nitrogen. It's an 83% product, which means it's 83% of this is actual nitrogen. This is a DMI toolbar, and this toolbar here in particular actually has the Case IH badge on it, as well as the DMI. It's during the crossover year, so it is a DMI painted red. This is a 15 shank unit, and this toolbar, as well as the tanks, is owned by the local co-op where we are getting our anhydrous from this year. We decided to use their toolbar. Normally we have a dual placer, and if you've followed the channel in the past, you'll have seen that toolbar and quantity cart. That is a 12-row, 30-on-row machine. We just wanted to be able to go faster this spring, get it done a little quicker, just gain the width. Their shanks were not quite as large of a soil disturbance as ours. We're a little bit dry this spring, so we didn't want to tear the ground up quite as much. And truth be told, this should have been done in the fall, which is a advantage of anhydrous ammonia, as it is a nitrogen product that, as long as soil temps are below 50, it can be applied in the spring or fall. I like to apply it in the fall because it allows time for it to bind up with the soil better. I just feel like you can reverse your compaction and the ground will retain, kind of seals itself back up, whereas the spring we're coming out here cutting the ground open. Now at the time of filming this, we were actually going through a pretty muddy part of the field. That part of the field will actually be getting some seam tile put in at some point. But generally speaking, our ground conditions are quite dry this spring. The anhydrous ammonia, it binds to the molecules of water in the soil, and that'll give you your nitrogen throughout the year for your corn crop. Right now, we're putting on an actual about 145 pounds. The rest will come from soybeans, and there's always some natural nitrogen that comes. Well, even lightning produces a little bit of nitrogen. There's always some from your organic material, and that'll give us a total around 185, 190 pounds, which and no-till conditions should be adequate to hit our full yield potential of this end of the farm, which does about 175. On a good year, it might reach 190. The main reason we like our dual placement toolbar is we're able to get the P and the K down in the ground. The nitrogen, of course, is going to be the same in the ground because the nitrogen knife, which is on this toolbar versus what's on the dual placement toolbar, is essentially putting the nitrogen in the same place. It's just that there's another tube for the P and K. And that allows it to get into those stratas quicker. If you're broadcasting on top and not working it in, the number one loss for P and K is erosion, but just don't expect it to get worked in very quickly. It takes a long time for that to go down, and oftentimes it just doesn't. It just gets tied up. Another reason we're using this toolbar, our dual placement machine, the meters on the back, they're a housing, and they have a cartridge that goes in. One of the meter housings is pretty much shot. It still works, but barely. And we are going to replace it with stainless steel meters. Those are unavailable because of all the shortages right now. We didn't get them ordered in time. So it just made sense on multiple factors to go this route for this year. Personally, I feel like we should have done it last fall because the price was cheaper then. And again, you get the freeze-thaw effects to take any compaction back out. Anhydrous ammonia is widely used, also widely criticized. There's a lot of misinformation on the product, as well as a lot of people think it's bad for the soil, or there's the old adage that kills all the earthworms. There are other products of nitrogen, such as dry urea or ammonium nitrate, but ammonium nitrate's very difficult to get, especially after Timothy McVeigh blew up the Oklahoma City building. It's explosive, and just because of the handling and there's just so many legalities to it, it's just become really hard to get anymore. But we like it because it stays on the ground. It doesn't vaporize, where urea either has to have a stabilizer or rain. And we're in western Iowa. We don't get a huge amount of rain. We've had 2 inches of rain all spring. You can use liquid, which is 28 or 32%. Again, those need to be rained in, otherwise they have a tendency to vaporize. Whereas anhydrous will bind up. We got just some subsoil moisture, so we're getting the shanks down, it'll bind up right away. We've, on our farm, have used the other products with some limited results, just because it's just too often our rainfall's sketchy and inconsistent. And you just tend to get a lot of vaporization on it, which what good is the product if it's just turning into vapor going out into the sky? As far as the anhydrous being bad for the environment, I personally don't feel it is, and there's multiple universities that back up that statement, that the old claim that destroys your ground is not true. I think there's a lot of just negative publicity in it. You don't want to over-apply. You want to look at your cation exchange capacity, which is also on your soil test. That's an easy one. You just take that number times 10. That's essentially what you hold. So say it's 17. You take that times 10 and hold 170 units of actual in at one time. That's an easy way to look at it. I think some guys have a tendency to over-apply, which either going out into the air or it results in actually it can eat up your lime because it becomes acidic if it's not used. Next up on the soil chart, let's take a look at phosphorus, a P1 and P2. You will note that they are in parts per million. And a P1 test is what's available now. A P2 test is what they think will become available in the future. In order to figure this on a 0 to 6 inch soil test, take, say, for example, the P1. If we're going to use the number 15, take that times 2 equals 30, then take that times 2.3, and that will equal your pounds per acre of phosphate. The reason we're using phosphate and taking that 2.3 because we're converting phosphorus to phosphate. And phosphate is what you will find on a removal chart or an as-needed chart for your crop production. I often get asked on this channel why we don't till. We are primarily no-till. Well, the answer for that is 2 reasons. The first being erosion. Our soil does not contain a lot of sand, which means it's more prone to erosion. And the biggest reason, we just like to build our organic material. The worst way to burn up your organic material is by tillage. It opens up, allows the oxygen to get in there, converts things over to sugars, and it burns up your organic material. Although organic material breakdown can be a bit tricky with no-till. So there are tools such as what you're seeing here, which we demoed a year ago. This is a 2660 vertical till John Deere, which just cut it up and put just enough black dirt in just to kind of make a mix. It did actually improve soil structure and health. But at nearly $100,000 for the tool only, not to mention the fuel time, effort, and everything else that goes into operating it, I just don't think that it's a tool that I can really... I would like to have one, but I just don't think I can really justify it. And a lot of that can go into your geographic location as to your freeze out or thaw dates. Up north, you're going to see more tillage than you do in south, and I use that in the terms of Iowa. The reason for that is the further north you get, the earlier it freezes the ground, and when the ground freezes, that breakdown to sugars tends to stop, whereas we have a longer season, so the burn of the organic material lasts longer. There's just so much that goes into that, and so much that goes into organic material, your breakdowns, your different types of your natural elements. You will get P and K naturally just out of plant breakdown. Topic for more videos in the future. But again, none of that matters if your lime and pH is not in check. So hopefully I put this video together in a way that's understandable and made sense, and maybe helped a few of you. Many more videos coming, as well as more in-depth into particular parts of what I talked about in this video. If you like these kind of videos, or like the channel in general, equipment repair to organic health, different types of farming, follow along. We got some pretty cool things coming up, not just farm equipment.